we're going to talk about our second component of our waves, currents, and tides standard. Our main learning target is I will analyze and interpret data to create graphic representations of the causes and effects of waves, currents, and tides in Earth systems. So we're going to be discussing ocean currents. An ocean current is a large stream of moving water that flows through the oceans. There are two types. The first type is a surface current, just like what it sounds. These are movements of water that occur at or near the surface of the ocean. Take a look at the graphic. There's a warm current and a cold current. Remember from a previous lesson that if it's warm, we can probably find it at the surface, and if it's cold, it's probably deep below the surface. Causes of surface currents. Global winds. That's just like how it sounds. These are winds that are blowing across the globe or across the world. We have trade winds that blow from 0 degrees to 30 degrees latitude in the northern and southern hemisphere. We have westerlies, which blow from west to east in 30 degrees to 60 degrees latitude in both hemispheres. And we have easterlies, which blow from the east to the west at 60 degrees to 90 degrees latitude in both hemispheres. We also have the Coriolis effect that causes surface currents. Coriolis effect is the shifting of winds and surface currents caused by the Earth's rotation. The Coriolis effect causes the direction to be curved. In the northern hemisphere, winds or currents blow in a clockwise direction. And in the southern hemisphere, they move in a counterclockwise direction, as noted here. So here are the global winds, and they are curved due to the Coriolis effect, which affects currents. Another cause of surface currents is continental deflection. That's when land masses or continents get in the way of moving water, and this causes the current to shift. So again, we can see that graphic a lot larger. In the northern hemisphere, we're noticing that the majority of the currents are moving in a clockwise direction. And in the southern hemisphere, they're moving in a counterclockwise direction. Notice that up against continents, they're moving in a certain way because the continent is in the way. The second type of current is a deep or density current. This is a current that forms when a mass of more dense water sinks beneath the less dense salt water. So we can guess that this current is cold. Remember those factors that affect density: temperature and salinity. Okay, if it's high temperature, meaning it's really hot, it's not going to be as dense. If it's a lower temperature and it's cold, it's going to be more dense than the hot temperature. Salinity. A lower concentration of salt is going to be less dense than water that has a higher concentration of salt. Remember, again, temperature and salinity affect the density of ocean water, and we can look at that graphic again that we saw in ocean composition. Notice that blue, dense, cold, high concentration of salt water sinks below that warm, low concentration of salt water. Here are just the movement of some currents over several days. There's some extra vocabulary that we need to be mindful of when we're talking about currents. The first is upwelling. Upwelling is the movement of cold water upward from the deep ocean. So sometimes that cold water does come up and then it eventually gets heated by the sun and becomes warm water. We also have something called a longshore current, which is a current that moves parallel to the shore, which results in longshore drift, which is the movement of water and sediment down a beach caused by waves coming into the shore at an angle. So here's a picture. We have our longshore current, which is moving parallel to the shoreline, which causes longshore drift, causes a zigzag motion with the sediment. Another vocabulary term that we need to know is a rip current. This is a rush of water that flows rapidly back to the sea through a narrow opening. If you're ever at the beach and you notice a rip current, you need to get out of the water right away. This can be very dangerous. Don't forget to answer your essential questions and use your notes if needed. Keep in mind your main learning target so that we can focus our learning.